Hello, this video is about power. Now, power is the probability that a fixed alpha level significance test will reject the null hypothesis when a particular alternative value of the parameter is true. That's called the power of a test against the alternative. The power of a test against this alternative is 1 minus the probability of type 2 error for that alternative. That is the power 1 minus b. Now that's just a bunch of words, isn't it? Let's see if we can explain what those words mean. Now, let's take, for instance, a distribution. Now, you may have noticed in my last video, I talked about the probability of getting a type 1 error. But I didn't talk about the probability of getting a type 2 error. So let's do the parametric example where I have 6.7 for a null hypothesis. And the alternative hypothesis was on the bottom. So if that's the case, we can, there isn't one type 2 error. There's a probability of type 1 error. Probability of type 1 is just going to be alpha. And typically that's about 0.05. For probability of type 2 error actually depends on an alternative mean. So we have to test a type 2 error at every single spot along here. And if you do it for power, it's called a power analysis, something that's not covered in AP curriculum. But typically we can just check one spot. So let's say if the mean is 6.5, let's say the 6.5 is about right here. What you'd have to do is draw a normal distribution around 6.5. And we assume that these standard deviations are the same. So this is a little tricky, so make sure you're paying attention to the wording here. So for our null hypothesis, here is that the mean is 6.7, with an alternative mean is less than 6.7. But it's possible that the mean is really 6.5. So if mean is actually 6.5, we'll get some variation like this. So it would be normally distributed, where you get some values above and some values below. Now if I drew a vertical line straight down here, maybe pink, going up. Now the probability that I fail to reject the mean when it's really 6.5 is over here. That is type 2 error. Or I should say the probability of type 2 error. And what they call that is beta. So beta is your type 2 error, and it's over here. Now, this other side is what we call power. So this blue is our power. It's kind of a complicated idea. A power is the probability that you reject the null hypothesis of 6.7 when the true mean is 6.5. Now, the type 2 error is the probability we fail to reject the null hypothesis 6.7 when the true mean is actually 6.5. Now, there are ways to increase the power, because typically you want a high power. So what a high power means, if the power is high, then that shifts this blue over here, and then it reduces your chance of a type 2 error. So we want at least that power of 80%, or 0.8. So there's some ways you can do it. The main thing is number 3. The book had these 4, and I think we can look at all 4 of them. But the main thing that people do to increase their power is increase the sample size. Because as you increase your sample size, your these the standard deviations get thinner, and as they get thinner, it's more easy to protect. It's more you're more able to see if there's a distinction between the two means. The second thing you could do is increase your alpha level. If you increase your alpha level, so if I move this green area up here, that's also going to slide this blue over as well. So that's a reasonable one. Consider an alternative that's further away from the mu. So if I picked up this point, instead of 6.5, if I move this way, the power, the blue part, is going to increase. And finally, you can decrease the standard deviation of the population. And I have no idea how you can actually do this because sigma is usually set by the data itself. But the main thing to look at is when you increase sample size, that reduces power. Also, increasing your alpha level. If you have a windmill, for the windmill problem, suppose the power is 21 miles per hour is 72%. Let's see what that means. So I'll draw this out. Ooh, that's not the one I wanted. So we'll have a null hypothesis of 20 miles per hour. And the power is 72% at 21. So 21 maybe is here. And if I draw the mean around 21, if I draw my line up, the power is saying that this over here is 72%. So if the mean truly is 21 miles per hour for that area, 72% of the time I'll reject this null hypothesis. So I'll write that out. So what the power means here is if, let's pick a better color than that. Let's do red. If the true mean is really 21 miles per hour, we will reject a null hypothesis of 20 72% of the time. Or maybe I should have said 72% of the time we'll reject a null hypothesis of 20. That probably would have been a little bit clearer. All right. Now that is power. Hopefully you can finish up.